So this video covers really simple file I/O, and what we're going to do is just read values from a text file and then use them. So the first thing I want to point out is that the file I/O stuff we're going to be using is in stdio.h. Now there are other includes that we might need down the road, probably not in this course though, but there are other includes that have to do with file I/O, but for right now we're just staying with the simple stuff. So let's talk about how to open and then how to close a file. There's actually what's known as a data structure, and by the way, asterisk means pointer. So this is a really it turns out we call these file pointers. So we're going to say fp equals fopen, and fopen is the command which is found in stdio that opens a disk file. Okay, so open paren, close paren. So what we're going to do here is we're going to say c work, and I have a file that I've already created, cop3223 is cool. Of course you guys all, oops, it is cool.txt, right? You guys all agree with that, I'm sure. We need another string though that tells fopen how to open this. This means open for reading text. W means open for writing text. RB means read binary. WB means write binary. Okay. Now, if we open this, we have to always make sure that we close it, because then the operating system keeps resources tied up while it's still open. There's also another very important thing I need to, cop. There's also another important thing I need to talk about. Backslash within C strings has a special meaning. As you know, we've talked about backslash n, backslash r, backslash t. These are what are known as escape sequences. So if we actually really, for real, want a backslash, we have to really use two backslashes. This is the escape sequence, and the next one is the type. So what this means is escape sequence, give me a backslash. Okay. Escape sequence, give me a backslash. Okay, so just remember that in the C, C++ language, even actually sometimes in the C# language, a backslash has a special meaning. So to get a backslash, we need two backslashes. Okay, so now I'm just going to run this real quick and just make sure everything works okay. That it actually opens. Okay, everything looks good. Now, if for whatever reason it doesn't open, fp will be null. So if fp equals null, and this is called error trapping when we're checking for errors. So what we're going to do, if it does happen to be null, we're going to say could not open the input file, and then we're just going to return 0. And from main here, return 0 is going to abort the program. And out here we're going to say printf file was successfully opened. Okay, so now let's go ahead and run it again and see what kind of message we get. Okay, it says file was successfully opened, and that's because this file, I had copied it out to the hard drive earlier. Now what happens if maybe I mistyped there? Okay, and this is a file that doesn't exist. So if I go ahead and run and build this, I'll get a different message, and it's going to say could not open the input file. Okay, so once again, this technique of making sure that everything happened correctly is called error trapping. Okay, that's the generic term for it. Oops. Okay. Now, to actually read this text file, we're going to use You all know already how to use scanf. Well, there's a special version of scanf called fscanf, which means just scan from a disk file. But first, let me show you the disk file that I've created. The first number says I have 8 entries, and the next are the actual data. Okay, so I have 8 data entries, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is the disk file we're going to use to go ahead and do this. So now the first thing we're going to do is we have to do an fscanf to figure out how many grades we have. These are grades that we're going to average. So what I'm going to do is say how many grades and declare this. Okay. Now we're going to use fscanf, as I've mentioned. Let me go ahead and fscanf. Here's the command. And what we're going to do is we have to put fp here. It needs to know what the file pointer is. It needs to know this is the same as scanf. Now this is the type of a variable. This is the ampersand and then the integer. And now it's going to tell us how many grades there are. That's just a simple printf. So we go ahead and run this and make sure that we're doing this right. Okay, it says 8 grades. And that actually turns out to be correct because this disk file that we're reading says 8 grades. Okay. So now the easiest way actually to read through all those grades is with a for loop. So now I'm going to read through all those grades. Okay. And let's go up and declare another variable up here called this grade. We're going to do this program kind of iteratively. Okay. So right now we're going to go ahead and do an fscanf. Now these grades are actually floats. They're intended to be floats. So we do an fscanf on that float and we tell them what the grade is. Oops, I did not declare I. Okay, so let's go ahead and do that now. Oh, actually, that did not work. I should have done this as a float. Sorry about that, Chief. Go ahead and run it now. Now everything looks correct. Okay. So now what we want to do is we want to get an average and find out what the min grade and the max grade are. Let's go AVG total equals 0, min, and the min we're going to set as a large number. Max we're going to set as a small number. Okay. So now then remember how you average numbers is you add up the number of numbers. So in the loop we're going to add up the number of numbers. Okay, this is adding up the number of numbers. And here we're just going to say, okay, if this grade happens to be smaller than min, we'll register the min as that grade. If this grade happens to be greater than max, we'll register the max as that. Finally, once the loop is done, we're going to go ahead and calculate the average. And we don't want to do it inside of the loop because remember how we average up numbers. We add up the number of numbers and then we divide by the, first we add up all the numbers, then we divide by the number of numbers. So this actually should work okay. Let's just make sure. Oops. Okay, let's go ahead. All right, there we go. Everything's good.